Welcome back. Today we are going to be going through lesson 4 or 5, which is all about writing a quadratic equation, given some different information. So before we get started actually writing those equations, we're just going to review quickly the 3 different forms we can have or we can write our equations in. So we have standard form, which is the most basic, with a as the coefficient of x squared, b as a coefficient of x, and c as a constant. Then we have vertex form, which looks like this. And as a reminder, in vertex form, we can find the vertex. It is the values of h for x and k for y. And then lastly, we have intercept form, which looks like this, sometimes also called factored form. And in factored form, we can see the x-intercepts as p and q. So we're going to use those 3 forms to write quadratic equations. So the steps are going to be the same. It's just going to depend on what information we are given and what we need to do from there. So for this first one, we are given the x-intercepts and a point. So we have x-intercepts at +1 and -2, and a point at 2, 12. So since this one is given the x-intercepts, I'm going to use that intercept form. So I'm going to use intercept form, which remember is y equals a times x minus p and x minus q. So what we're going to figure out is that our point is going to give us the x and y values, and the x-intercepts are going to give us the p and q values. So our y value from the point is 12. I don't have an a value. My x-coordinate is 2. My p value in this one is 1. My x value is again 2. And my q value on this one is -2. So we're going to use the information we're given to write it. In this case, the variable we don't know is a. So we're going to plug in all the variables and solve for the ones we don't. So using what we already did here, we're going to say 12 equals a times 2 minus 1, and then I'm going to write this one as 2 plus 2. So simplifying, I get 12 equals a times 1 times 4, and that's going to get me that 12 equals 4a. So a is 3. So I've solved for that unknown that I had. Then I'm going to write the function in intercept form, so write it all out. So we're going to have x minus 1 and x plus 2 with that 3 plugged in for the a value. So that would be my intercept form. And then it also wants us to write it in standard form. So we're going to multiply that out. So I'm going to FOIL together the 2 binomials. I'm going to get x squared plus x minus 2. And then distributing that, I get y equals 3x squared plus 3x minus 6. And that is my standard form. And then lastly, you can graph your 2 forms to double check. We want to make sure that we end up with those x-intercepts at -2 and +1. We want to make sure that when we graph it, it goes through the point 2, 12. So again, you're going to graph it on the calculator to check these things. And we're going to make sure that it makes that nice parabola shape that's going on here. So you're going to graph it and make sure it actually hits those 3 points. Next up, we are going to go through a similar process, but this time, instead of being given the intercepts in a point, we're given the vertex in a point. That tells me that I should probably use vertex form. So in vertex form, remember we need an a value, an x, an h, and a k value. So looking at what I have up here, my point is always going to give me the x and the y coordinate, and my vertex is going to give me the h and the k values. So I've got a -13 for y an x coordinate of -2, an h of 1, and a k of 5. So again, the one I don't know, the variable that's left is a. So I am going to plug everything in and see what I can get out. So I have -13 equals a times -2 minus 1 squared, and then plus 5. So simplifying that to solve, I would end up with a times 6, so 9. -3 is squared is 9. So this would give me 9a plus 5. And then when I solve that equation, I would get -18 equals 9a. So the a value is -2. So once I know that, I can write everything out in its form. So in vertex form, it would look like -2 times x minus 1 squared plus 5. Again, that's our vertex form. And then multiplying it out, let's see, I'd get -2. I'm going to go ahead and square that binomial out. It would give me x squared minus 2x plus 1. And then distributing and combining like terms, I'd get -2x squared plus 4x. And then I'd get -2 plus 5, which is 3. So there's my standard form. Okay, so for this last one, instead of given coordinate pairs of any sort, vertex, intercepts, or any other points, we are just given the graph. So for this one, you're going to look at what key points you're given on the graph. And really for this one, I can see the vertex clearly, and I can also see the intercepts clearly. So it's really up to you which one you want to use. For this one, I'm going to go ahead and go with intercept form. But again, you can pick anything you want. So I need the intercepts, and then I need another point. So looking at my graph, it looks like I have another point, the y-intercept there. So I'm going to use this point, which is at 0, 6, and these two x-intercepts, which are at 2, 0, and 6, 0, to help me solve this. So plugging those in to intercept form, I'm going to have 6 equals a times 0 minus 2 and 0 minus 6. So simplifying that, I get -2 and -6. So that's going to give me 6 equals 12a. And then dividing that, I get 1/2 for the a value. I skipped ahead a little bit and I labeled them on my graph. So we've got our vertex and our points. The vertex for this one, if we wanted to use that, is at 4, -2. So you can choose if you want to do it in vertex or intercept form. All right, so once I've got it, I'm going to take my intercept form that I now know, and I'm going to multiply it out to write it in standard form. So again, I'm going to multiply those binomials together, get x squared minus 8x plus 12, and then distribute. So my standard form is 1/2 x squared minus 4x plus 6. Okay, let's go ahead and practice some here. So I would encourage you to pause the video and try some of these on your own using our examples that we've done, and then come back and check your work. So for this first one, I am given the x-intercepts and a point. So I'm going to go with intercept form on this one. So I am going to plug everything in where it goes. So my y value is -6. I'm going to find the a value. X value is 2. And the intercepts are at -1 and +3. So it looked like that when I plug everything in. Let's simplify that a little bit here. So I get -6 equals, when I simplify those, I have a 3 in the first parentheses and a -1. So that's going to give me -3a. And simplifying that, I get that a is 2. So my intercept form would look like 2 times x plus 1 and x minus 3. And then it says we should also write it in standard form. So I am going to go ahead and multiply those together. So I'm going to get x squared minus 2x minus 3, and that's going to give me 2x squared minus 4x minus 6 for my standard form. Now, number 2, they're giving us the x-intercept again. This one only has one solution, so that means that 5 is going to be my only x-intercept. So when I plug these points into intercept form, I'm going to have a y value of -5, an x value of 2, and then I'm going to subtract 5, and my second factor is going to be exactly the same. So when I simplify those, I get that -9 equals 9a, so my a value is -1. So when I write that out, I get -1 times x minus 5, and again, it's the only solution, so we write it twice. We can't have it once because then it would be a linear function, so we have it twice to make it that quadratic function. So there's my intercept form. Now let's multiply it out to get standard form. So that's going to give me a standard form of -x squared plus 10x and minus 25. All right, 3 and 4. So number 3, we are given a vertex. So I'm going to write this one in vertex form. So with my vertex form, I'm going to plug in my y value. That's 3. Remember, that's the y. Equals the a value times the x, which is also 3, minus h, x of the vertex, squared, and then plus the y value, which is -1. So there's what it looks like. Now I'm going to simplify everything to find that a value. So when I simplify there, I get 4a minus 1. And so when I solve that equation, I get that a equals 1. So when a is 1, we don't actually need to write it. You can if you want, but it doesn't do anything to the equation. So I'm just going to write it as x minus 1 squared minus. Okay, multiplying that out now. When I square x minus 1, I get x squared minus 2x plus 1. And then simplifying, I get a standard form of x squared minus 2x, and then plus 1 and minus 1 cancel out. So that would be my entire standard form on this one. Okay, number 4, we're given the vertex again. So I'm going to go into vertex form. So my y value is -3. I'm going to have to find my a value. X is 1 minus 0 squared plus 0. So simplifying that, we would have 1a. So that tells me that a is -3. My vertex form, therefore, would be -3 times x. And then I can write in the zeros, but again, they're not really going to affect it. So essentially, my vertex form is my standard form because it's just -3x squared. It's kind of a different one there because that vertex is at 0, 0. Okay, here we are given the graphs. So on this first one, I can pretty easily see the intercepts here. So I'm going to write this one in intercept form. So my intercepts are at 1, 0 and -5, 0. And I can see that the y-intercept is at 0, -5. So I'm going to use that as my other point. So I'm going to plug that in here and say -5 equals a times 0 minus -5 and 0 minus 1. So when I simplify that, I have a times 5 times -1. So my a value in this situation is 1. So when I write that out in intercept form, it would be 1. Again, we don't have to write the 1 because it's multiplying, so it's an identity property. So I would have x plus 5 and x minus 1. in that intercept form. Multiplying those together to standard form, I get x squared plus 4x minus 5. Okay, and this last one, my intercepts are not nice points here. So I am going to go with vertex form on this one because I can see that my vertex is at -2 and up at 5. And then I can find another point to help me. I can see right here that this point is at -1, 1. So I'm going to use that other point in my vertex form. So when I plug those in, I would get y equals the a value times x minus ch squared plus k. So simplifying that, we would get a times 1 plus 5. And so when I solve that, I get that the a value is -4. When I write that in vertex form, it would look like -4 times x plus 2 squared plus 5. Ran up against that a little bit there, sorry about that. And then when I multiply that out, I would get -4 times x squared plus 4x plus 4, and then plus 5. And so my standard form, when I simplify it all out, would be -4x squared minus 16x, and then -16 plus 5 would be -11. That is how we write quadratic equations given different information. We'll see you next time.